Hello my dear friends, hope you are doing well. I welcome you all in yet another video on how to read Dumpy level, which is a very important tool for any installation engineer on site. Without this, one cannot even imagine of alignment of heavy machine used in industries. Being from a mechanical background, it was a strange thing for me as well when I first encountered this tool. But today, my day starts with Dumpy level and ends with it. I will try to keep it as simple as possible so even a primary class student will understand it. Okay, so without wasting much time, let's get started. So, what you can expect from this video? It will contain the introduction of Dumpy level and what is its use. Second one will be the parts of Dumpy level and what are its functionalities. Third will be the setting of the benchmark, how we are going to set the benchmark of the Dumpy level. Next will be the final elevation reading of any point with respect to our set benchmark. And lastly, there will be small calculation that is involved for the elevation difference. So I hope you are excited for this video. Let's move to the next slide. So what is Dumpy level? Dumpy level is nothing but an instrument that we are using to take elevation reading with a set benchmark or a reference point. This is a layman language definition that I have developed over the period of time. There might be different technical definition of Dumpy level, but I find this to be short and sweet. The elevation reading that we are going to take from Dumpy level will always be in relative term with respect to the benchmark. Okay, the first thing to be noted. So moving ahead, it is a very important and easy to use tool for alignment purpose. Okay, so let's see what are the parts of the Dumpy level and what is their functionality. So as you can see here, let me, yes, as you can see here, this is our Dumpy level machine. Okay, this is the tripod on which this Dumpy level rests. You can see over here, this is the adjusting screw through which we adjust the height of the tripod based on our convenience, so that if we are standing and seeing through the eyepiece, it would be convenient for us to see this. This is the box in which this tool is kept. So let's move to our next slide and see what all other parts of the Dumpy level are. Okay, so let's move to the next. So here comes the focusing screw. This screw help us to get clear image of the staff reading or the scale reading when rotated in clockwise or anti-clockwise based on the distance the staff is being held by the person. Okay, these are the angle rotating screw through which we can rotate the Dumpy level in the horizontal plane towards this side or towards this side. Okay, and these are called the leveling screws. These are three in numbers. With the help of these screw, we will maintain the Dumpy level in horizontal plane, and that can be seen through a bubble that is located on the other side. It will be shown in next slide. That will be located on other side through which we can see the eccentricity of the bubble that we will discussing in next slide. So next. So let's see the other part of the Dumpy level. It is called the telescope through which we are going to see the staff reading. It is the eyepiece through which we are going to take the reading. Okay, by keeping one eye closed, and this is the foot plate through which the Dumpy level is connected through the tripod. Okay, so quickly we'll see parts. What I was telling in the previous slide, this is the bubble tube through which we can see the bubble, and this is the lens, this is the objective end opposite to the eyepiece. Okay, so this is the focusing screw, this is the leveling screw, this is the objective end, this is the bubble tube, this is tripod. This is all about the parts of a Dumpy level. So next we will see. So the first step will be setting of our benchmark or reference from where we are going to measure our rest of the elevation. Okay. Before taking the elevation reading, we will set our dumpy level. We will ensure that the bubble is in the center of the bubble tube or not. Okay, with the help of the focusing screw, we will focus our eyesight towards the staff reading. When seen from the eyepiece, you will see these three crosshairs. One will be small and one will be larger one. So we have to focus our attention on the larger one because this one will be our elevation reading. So in this case, let's assume the benchmark reading comes out to be 1400 mm. Okay, so let's proceed. So after calculating the benchmark reading, we will proceed for the elevation reading at various points. As you can see, that person has moved from this benchmark to that point. Let's suppose that point we will call it as A. You can see that person is holding the staff or scale in perpendicular direction, which will be ensured by the spirit level which he is holding behind the scale. Okay, and from here we are going to see the elevation reading of that particular point. Let's suppose in case 1, the elevation reading of that particular point comes out to be 1395 mm. And in second case, let's assume the elevation reading is coming out to be 1404 mm. So we have to calculate elevation difference in order to check whether that particular point is above or below. That means it is up or down with respect to our reference point. So there is very simple formula to calculate the elevation difference. That will be equal to benchmark reading minus elevation reading at point A. So in case 1, the elevation difference comes out to be plus 5 mm by substituting the benchmark reading and the elevation reading. And in the second case, the elevation difference comes out to be minus 4 mm. So what conclusion can be drawn from plus 5 mm and minus 5 mm? Let's see. If the elevation difference comes out to be positive, that means that particular point is up with respect to our reference point and vice versa. So this is the crux of the video, which means if it's coming out to be positive, that particular point will be up with respect to our reference point, and if it comes out to be negative, that particular point will be down with respect to our reference point. It is as simple as that. So in case 1, as you can see, the elevation difference has came out to be plus 5 mm. That means that particular point is 5 mm up with respect to our reference point. And in the second case, the elevation difference has comes out to be minus 4 mm, which means that particular point is 4 mm down with respect to our reference point. Isn't it very easy? Okay, if you have liked this video, please do share to your friends so that they can also understand how to use the dumpy level. And if you find this informative, please do like and subscribe to my channel. I will bring more such videos in future related to the works involved in the installation of heavy machineries used in cement plant. Till then, take care. Love you all. Jai Hind.